Abundant source of free, renewable energy that could be used to heat a house in the winter, cool it in the summer, and provide hot water all year round? Well, a growing number of homeowners say there is, and it's powered by the sun. While you may be picturing solar panels, these homeowners are actually talking about geothermal. If you're a typical homeowner, almost 2/3 of your total energy bill is for heating, cooling, and hot water. The rest is for lighting, appliances, and other usage. That means the biggest opportunity to save money on your energy bill is to increase the efficiency of your heating, cooling, and hot water system. A geothermal heat pump taps into the renewable solar energy stored in the ground to provide savings of up to 70% on utility bills. Although it operates similarly to a standard heat pump, a geothermal heat pump exchanges heat with the earth instead of the outdoor air. Outdoor air temperatures can vary greatly from day to night or from winter to summer, while the temperature just a few feet below the Earth's surface stays an average 55 degrees to 70 degrees Fahrenheit year-round. To see why that's so important, let's look at traditional conditioning systems. In order to cool your home, an ordinary system collects indoor heat and expels it outside. Unfortunately, summer temperatures can easily hit 90 or 100 degrees, which means outdoor air already is filled with heat and is less willing to accept more. The exchange process becomes harder and harder. The result is that an ordinary heat pump or air conditioner becomes least efficient at exactly the time you need it to be the most efficient. A geothermal unit never sees hot summer air. It collects heat from your home and moves it to the much cooler 55-degree Earth. It doesn't matter how much outdoor conditions fluctuate, the ground remains relatively constant. Thanks to the constant temperature of the Earth, a geothermal heat pump is more than twice as efficient at cooling than any regular heat pump or air conditioner. To warm your home, an ordinary heat pump reverses to collect outdoor heat from the air and move it indoors. Unfortunately, as winter temperatures drop, there's less and less available heat to collect. Again, the exchange process becomes harder, and the heat pump becomes least efficient at exactly the time you need it to be the most efficient. A geothermal unit never sees cold winter air. It draws from a reservoir of much warmer 55-degree temperatures, concentrates it, and moves it to your home. And, unlike a traditional furnace, which returns less than 96 cents of heat for each dollar spent burning expensive, polluting fossil fuel, a geothermal heat pump returns up to $5 of heat for each dollar spent on electricity. That's because, unlike a furnace, a geothermal heat pump doesn't create heat through combustion. It simply collects and moves it. Now that you know the benefits of using the Earth, let's look at how it's accomplished. A geothermal system uses a series of underground pipes called a loop. The Earth loop eliminates the need for fossil fuels. It's the heart of a geothermal system and its biggest advantage over ordinary heating and cooling technologies. Closed-loop systems circulate a water-based solution through a collection of small-diameter, high-density polyethylene underground pipes. There are three main types of closed-loop systems. Where space is limited, vertical loops are used. Well drilling equipment is used to bore small-diameter holes from 100 to 400 feet deep. Horizontal loops are generally preferred where more space is available. Pipes are placed in trenches that range in length from 100 to 400 feet. If a nearby body of water is available, it can be utilized for a pond loop. Coils of pipe are simply placed on the bottom of the pond or lake to capture the geothermal energy. Open-loop systems are an option if water is plentiful and low in minerals. These systems use groundwater from a well as a direct energy source. Geothermal systems are recognized by the United States Environmental Protection Agency as the most environmentally friendly, cost-effective, and energy-efficient heating and cooling technology available. Geothermal heat pumps help electric utilities achieve significant reductions in their peak demand loads. By reducing the demand on electric utilities, geothermal systems reduce the need for new power plants, which typically are powered by coal or natural gas. Compared to an electric resistance heating system, a typical 2,500 square foot home with a geothermal system can save the electric utility company more than 9 tons of coal a year. These systems also minimize the threat of acid rain, air pollution, the greenhouse effect, and global warming, problems directly linked to the burning of fossil fuels. In fact, installing a single geothermal unit is the environmental equivalent of planting 750 trees or removing 2 cars from the road.